Yo, Chuck.
Hey, what's going on YouTube? In this video, I'm going to show you how to make a linked list, and I'm also going to show you every method that you're going to need to know when you make a linked list. So without further ado, let's get started. So the first thing I'm going to do is make a class for my linked list. Just call that linked list. I'll make a constructor. And recall that a linked list is just a connection of nodes that are linked together. So the first node is called the head node. So we could just say this.head equals null, this.tail equals null. Don't forget your semicolon here. And then also we want to put the length. So every linked list would have a length property. And let's just set that to 0. And recall that all the class constructor is doing is it's going to create an object that is of the class linked list, and it's going to have the properties of head, tail, length, etc. Okay, so that's all good and dandy. Now we need to make a class called node, because every linked list is comprised of nodes. So a node is going to have a value we pass into the node. So you just say value. We'll say this.value equals value. And then nodes are also connected by pointers. We use the word like .next. It's just a property that points to each node, to the next node. So we'll say this.next equals null for now because we have to link these nodes. So we can just save that. I'm going to create an object using the linked list class. I'll call it list equals new linked list, just like this. And now I'm going to console out this list that I just created, which is just an object, recall. Okay, so if I come into my file here, I'm going to use node and run it. Okay, so you can see we have the linked list. It has a head of null, tail of null, and length of 0. That's everything we want to see, so that's looking good. So now we need to add some nodes to our linked list. This brings us to our first method called push. And push is just going to take a value that we push into it. Now, if you're familiar with arrays, there is a push method that is used on arrays, and the idea being that you can push a value to the end of an array. So you're appending a value to the end. In the case of the linked list, we're going to be pushing a node to the end of the linked list. Now, if the linked list has no values, then we need to set the push method to set the tail and the head to the same node because there's no nodes present. So by pushing one on, by default, that node is becoming the head and the tail. So let's do that first. So I'll say let node equals, and I'm going to instantiate a new node object using the node class down here. That's why I'm using the new keyword. And I'm going to pass in the value that we push in here to my node. And what I got to do now basically is I need to check, is there a head node present? If there isn't, then I know that this list has a length of 0. So I'm going to say if this dot head, and I'm going to use the not symbol here. So that's basically saying if head is null or it's falsy, then I want to do something. So if this is the case, just like I mentioned, you want to come in here and set the head equal to node, and this dot tail equal to node as well. And if that isn't the case, so if there are nodes present, then I want to take the tail that is present in my linked list, so this dot tail dot next, and set that equal to node. So I'm basically taking the tail and I'm saying, hey, I want the next node to be the node that I just created here. Okay? And now I got to update the tail value. and that is going to be the node I just created. And down here, since we're using push, we need to increment the length. So I'll do that right here, and I can save that. Now you might be like, well, Chuck, there's two, this.tail equals node in either if-else clause. Can't you just delete that? Yeah, you could. You could just do this because dry code is best, right? So I'm just going to delete that. It's redundant. And I just moved it down here. So that's what we've done. Okay, so now let's push some nodes onto our linked list. So we'll say list.push because that's the method we created. And I'll put in some random values. Nothing particularly fancy, just random values. Okay, now when I console out my list, I want to see what happens. All right, so you can see the head has been populated by 4, 5, 6, which was the first node that I pushed on, so that makes sense. And then the tail should be the 14, and it looks like it is. So that looks good. Traditionally, people, when they're testing a linked list, they don't do it like this in the sense that they don't just console out the list. They usually have a print method which will print out the values of each node because that's just easier to see and understand. So let's make that right now real quick. So I'm going to come in here and I'll say print. Now let's do a check. I don't want to print if there's no nodes present, so I'll say if this.length is equal to 0, then I'll want to say something like there are no nodes to print, and then just return. So basically the user can't print if there's no nodes to print. Okay, so to print nodes, we need to be able to traverse the linked list. This is a word you hear all the time, traverse the linked list. What it basically we have to do is we just set a variable, we'll call it node, it could be called anything, and we'll say it's equal to this.head. So I'm setting it equal to the head node. Now I'm going to cycle through the linked list by using a while loop, and I'll say while node. Inside the while loop, I'll say node equals node.next. And I'm going to console.log node.value. So let me unpack what we're doing here. So we have this node which is initially set to the head value, and then we're going inside a while loop and we're saying while node is truthy. I could also say while node does not equal null. Do this, but it's easier and best practice just to say while node. And then I'm going to console.log every value in the linked list by using the console.log statement here. And then notice that I'm saying node equals node.next. So what eventually is going to happen is this while loop is going to node.next to a value that's null, and then it's going to stop. Okay, so that looks cool. Let's print this out. And now I'm actually going to remove this console log list because I don't need it anymore. And I can just print it out with my print method. And if I come into my console, there you can see that I'm printing out those values as we want it. That's cool. So another thing I like to do is just to make sure that I know what's going on, I might print the length. And I'm using template literals here, and I'm going to say the length is this.length. So let's see what that looks like. So now you can see I know the length of the linked list, and also for educational purposes, let's also put the head. So this.head of the linked list. Sorry, my keyboard H key is all messed up. So we'll say this.head.value because I want to know the value of the head node. And then also let's do tail as well. This.tail.value. So now you can see that it's a little more descriptive and easier to see where we are. Okay, cool. So now the next method I want to show you is the Unshift method. So whereas the push method will push a node to the end of the linked list, the Unshift method will prepend a node to the beginning of the linked list. So let's make that method now. So it's Unshift, and it's going to take a value, and it's very similar to the push method. So I'm going to have a node equal new node, and that's going to take the value we push in. And then also here, the same logic applies. We have to check if the head exists or not. So we'll say if this dot head, so if it doesn't exist, then we know this dot head equals node, this dot tail equals node. Else, we need to prepend this value. So what we can do is just say node.next equals this.head. So now the node that we created here is pointing to the head node. And then we can just say that this.head equals node. And now we've successfully tied those two together. And then don't forget every time to increment the length of your linked list. So let's try this method, very similar to push. And let's use a value like, I like to use 99 for these because it's very easy to see. So test it out. Cool, you can see it's adding 99 and it successfully increased the length and adjusted the head and tail. So that's good. Okay, now we're going to switch gears and go over the pop method. So pop, if you recall, in arrays, pop would remove and return the last value of the array. So in this case, we just want to grab that very last node at the end of our linked list, and we can return it or we can just delete it. Doesn't really matter. I guess it kind of depends on what the needs are for your business or for your project or your whiteboard interview. In this case, I'm just going to delete the node, okay? So I'll make a method called pop. And the first thing we need to check, is there a length? Because if there is no length, then there are no nodes to pop. Therefore, we should just get kicked out, right? So we'll say if this dot length equals 0, then we want to say something in the console like there are no nodes to pop. And then we can just return this, okay? And that'll stop us from just popping something that doesn't exist. But what if there are nodes to pop? Well, then what we can do is we have to traverse to the one before the last node. So I'm going to say let node equal this.head. Let prev equal node. So I'm initially setting both of these values to each other, and I'm going to traverse the linked list like we did with the print method. But let me show you something. So we'll say while node.next, and then I'll say prev equals node, and then node equals node.next. All right, so we're doing the exact same thing as before. We're cycling through the nodes with the node equals node.next every iteration of the while loop. What's different here, you'll notice, is we're using .next. So basically, we're going to stop one before the end of the linked list, right? And notice that I am setting prev to the value of node, but it's going to stop one iteration short of what the node becomes. So actually, what I have now is prev is the second to last node in my linked list. So if I want to do pop, I can just set prev.next equal null, and then this dot tail equal prev, and then decrement the length. So now if we go and try out pop, I'm going to delete, by the way, this unshift, just so we have these 3 nodes to work with. Let me run these again. That's looking good. Notice the head and the tail. Okay, now I'm going to do list.pop. And what should happen here is we want to delete the 14, right? And it looks like it did, and a length of 2, and then the tail's updated and the head's updated. Let's run that a couple more times. This is what you do, is just test to make sure your code's not broken. Okay, so that looks good. Let's do it one more time. Perfect. And then notice how there are no nodes to print, so it can't print anything. Awesome. So that looks good. Let's do list.pop one more time. I want to trigger that error message. There you go. There are no nodes to print. Cool. So that one works. That method's good. So like pop, where it deletes the end of the linked list, there's a method called shift, which if you recall from arrays will delete the first item in an array. So shift to a linked list is just going to delete our head. Okay, so, and we're going to have to obviously recalibrate the head of our linked list once we run the shift method. So let's make the shift method now. So shift, again, I'm going to do a check. Is there length on this linked list? Console.log. There are no nodes to shift. And just return. Okay, and then else. So what's the best way to do it here? So what we should do, since we're gonna delete the head. We know we're gonna delete the head, but we need to capture the node after the head. So what we can do is make a temp variable. We could call it node or temp or whatever, and just say this.head.next. Okay, so we've got that node captured, and then now we can just come in here and say this.head equals node, and then decrement our length. And that should delete our head node because we're just assigning it the value of this node, which is the next. And we're decrementing the length, so that should be good. Let's double check. So again, here's my values, length of 3. Let's do list.shift. And what we should expect to see is 456 is deleted. It is. Let's run it a couple more times just to be sure. What's happening here? Oh, I didn't spell list correctly. Okay, cool. And then one more time. Actually, let's do it 2 more times, just like we did with pop. Can never be too safe with this. No nodes to print, and then one more time to trigger that error message. Cool. Okay, so that method's down. All right, so now we're going to switch gears to the get method, and get method is just like an index for your linked list. So it's going to retrieve a node based on index. Now, an index for a node is just going to be like an array. So I'm going to have index 0 would be 456 because that's the first value. Index 1 would be 294. Index 2 would be 14, etc. So this get method is pretty important because we're going to use it later. But let's just get started. It's going to take an index. So we're going to pass in an index value. So first things first, we're going to check if it's a valid index, right? So if index is less than 0 or index is greater than this.length minus 1. Recall that we are making our linked list 0 indexed, therefore this.length minus 1 would be the very last value. So if we're saying if the index is greater than that, then we know it's an invalid index. So we can come in here and say console.log invalid index. Return. Okay, else if it is a valid index, we are going to say make a count variable, set it equal to 0. We're going to pretty much traverse the linked list again like we did originally. We'll say while count is less than index, we're going to increment count. But notice here, I'm going to use that same traversal logic and say node equals node.next. So now when I run this logic and I pass in an index, say like 2, count is going to increment twice, and then this node.next is going to be fired twice. And it's going to give me a node that I want. So what I'm going to do just for purposes of education here, I'm going to just log out the node value. But also you want to return the node. That's the main purpose of this get method, is returning the actual node. Because like I said, we're going to use this get method on a couple other methods coming up. So let's return it, and then let's just try and see if we can get that to work. So list.get, let's pass in index 0 at first. Node is not defined. Okay, so don't forget to, like we're traversing a linked list, right? Let's make that node equal to this.head, because we're starting at the head and then we're using node equal node.next to traverse the linked list. Let's try that again. So I'm getting index 0, and it looks like it's shooting out right there. I don't like how that is presented, so let's do this. Let's use those template literals again and say get, and then we'll pass in the value, node.value. So it's a little more clear to like what I'm doing. There you go. So now you can see it better. So get 456 at index 0. That makes sense. What if I put in index 1, 294, and then index 2, 14. Excellent. Now let's put in a invalid index like 3. Invalid index, and then how about -1? Cool. Invalid index. So that works. So if you can make the get method, the set method is actually really freaking easy. So all you got to do is do set index value. So set is just going to grab a node at your specified index and change the value to whatever you dictate. So same thing applies with the if-else check at the beginning. You want to say if index is less than 0 or index is greater than this.length -1. So you're saying, hey, if the index is less than 0, then it's invalid. And if it's greater than the last element or the last node in my linked list, it's also invalid. And again, if you're smarter than me, you can probably just copy and paste it from up here. Yeah, I would say invalid index and then return. Okay, so else, now we need to get this value. We can store the value using the get method and apply it to a variable. So I'm going to do that. I'm going to say let node equal this.get, and then I'm going to pass in the index. Okay, that looks good. And then I'm going to set node.value equals whatever value I pass in here. And then notice how this is highlighted when I pass in value. See that? That's how you know it worked. Okay, so that looks good. Let's test it out. I'm going to start by targeting index 0. I'm going to set it to 99. There it is, 99. All right, let's do it to index 1. I'm just walking the dog here to make sure that it works. That looks good. Index 2. Let's try an invalid index like 9. Invalid index, perfect. So that looks perfect. Okay. Okay, let's do the delete method now. So delete takes an index and deletes a node at that index. So There's a bunch of ways to do this. I kind of use a lot of like if-else conditionals. So let's start with checking if there are even any nodes in the linked list. So we'll say if this.length equals 0, I want to say console.log there are no nodes to delete, and then return. And then now we'll do our check with the index. So if index is less than 0, we know that's invalid. Or if index is greater than this dot length minus 1. We're going to use that invalid index talk, all right? Now here's where the fun part is. We can use those prior methods to just do most of the dirty work for us. So I'll say else if this dot index, or sorry, if this index equals 0, what can we do if we want to delete the very first node? We can just use this dot shift, if we can spell it, that is. So that makes that easy. And then also, what if we want to delete the very last node? So we'll say index is equal to this dot length minus 1. What deletes the very last node from a linked list or an array? The pop method, right? So there we have two edge cases for when we need to delete the very first item and then where we need to delete the very last item. So that makes that easy. And then we can come down here, and then now we need to basically grab the previous node and then the next node after the index, and then link those two up together and then delete that middle node. So how am I going to do that? Well, I'm going to make a variable, say prev, and use my this.get, pass in index minus 1, and then make another variable called next, and use the this.get again, and we'll use index plus 1. So when the user specifies an index, we're going to grab the one before it and the one after it. And then we're going to sync them up together and link them together like this. So we'll say prev.next equals next. And then, of course, we're deleting the node when we do this, so we need to decrement the length. Okay, so that looks pretty good. Let's test it out. Oh, try not to dox myself here. Let's test out our linked list real quick. Node test. So it's got those 3 values. Let's say I want to delete value at index 0. Cool, and also notice it's deleting the value, and check the head and the tail. And let's make sure these are right. So I'm going to delete the first one twice. And notice it's working. That looks great. So do it again. There are no nodes to print. Let's do it a 4th time. There are no nodes to delete. Excellent. Let's remove that. And let's try deleting at the very end. So I'm going to delete 14. I should delete 14 here. And it looks good, and it's updating the head and tail. Let's delete 294 now. Excellent. So that looks good. Our delete method looks pretty good. Now, again, there are other ways to do this. I'm sure this is what I've found works best for me, is kind of like checking are there nodes to delete and then using that index check. And then if it's the first node, we can use shift. If it's the last node, we can use pop. Otherwise, let's use this magic with the get method we've already made. So that's delete, okay? Now we need to make a method called insert. This is probably my least favorite, and I'll tell you why, because it's unclear when you're doing this. People say, oh, you just need to insert it at an index. Like, that's the idea of insert, is you're going to insert a value at a specific index. Well, the problem with that is, are you indexing it to the left of the, are you inserting into the left of the index, or are you inserting to the right? So there's kind of some ambiguity there. Personally, me, I just say, hey, screw it. I'm just going to insert to the right of the index. So that's what we're going to do here. I'm going to make a check if this.length equals 0. And I'll say, you need to add nodes first to insert. And return, just doing some edge casing real quick. And then also, let's do our check for valid index. Index is less than 0, or index is greater than this dot length. Notice I'm not doing this dot length minus 1 because it can be greater than this dot length minus 1, right? Well, actually, no, I guess you would have to, no, you'd have to put it like this. You'd have to, you want to be able to target the very last node, and you'll just add to the right of that node, if that makes sense. So we'll do our console.log for invalid index. I was thinking like just to make it this.length, but that would give us one too far in the future. We actually want to be able to target the last node index because then we're just going to add to the right of it, okay? Okay, so those are our two little edge case checkaroos. Now we can come in here and do else if, and we want to add to the right. So if index equals 0, right? So if it's the very first one and we want to add to the right. Okay, so if index is 0 and we want to move our value to the right, what do we need to do? So firstly, we need to say let new node, let's call it new node, equals new node, and then pass in that value. And then we need to get the value of next, of head.next, right? So what we're going to do is say this.head.next equals new node, which is the node we just created. And then we're going to say new node.next equals node. So you're inserting that new node in between the head and its next node, if that makes sense. Kind of confusing. I could see why. All right, so that is an edge case if the index is 0. Now, if the index is the very last node in the linked list, or if index is equal to this dot length minus 1, we can just cheat here and use this dot push and then pass in the value. So these are our two edge cases right here that we just did, right? These are the two edge cases if the node is at the start, inserted at the very first index, or if it's inserted at the very last index. Because again, we're pushing our node to the right of that index. So now we need another way to traverse our list and insert the node if these edge cases aren't triggered. So what I'm going to do is say let prev equal this dot, actually no, we're going to use current. We want the current value, so we'll say this dot get index. So I'm going to get the current value. And then we need the next value of the current. So we'll say let next equal this dot get index plus 1, right? So we're getting the current value, and then we're getting the next value after current. And then we're going to say, we're going to use this node, new node logic here. Copy and paste that bad boy. We'll say current dot next equals new node, and then new node dot next equals next. And then of course, because we are inserting, we are adding to our length. So I'm going to increment length. Okay, that was a lot of stuff. Let's run this guy and see what happens. I'm going to erase these delete ones, and then I'll add our insert method. So we're going to insert at index 0, and let's use 99 because that's easy to see. So what I'm expecting to happen is have 99 sandwiched in between 456 and 294. So that looks good. Notice the head and the tail also, and then let's try index 1. Again, I'm just walking the dog here to see if I can screw it up. So it's kind of cool. So when I did insert index 2, it's updating the tail because, again, it's using that push method. So I'm kind of like cheating a little bit, right? And it's pretty nice. Okay, so did we do index 0? I forget. And that looks good. Let's do an invalid index like -1. Just to see if I can trigger that invalid index. Let's do 3. Awesome. So that looks good. That is the insert method. That's one of the harder ones. If you can master insert right here, you'll be pretty good. Okay, let's do the hardest one unequivocally that everyone knows, which is reverse. All right, so with reverse, we're just going to reverse the linked list, right? So conceptually, this is kind of hard to understand for most people, including myself. I kind of think I got it, but can I explain it well enough? That's up for debate. I can kind of guide you through it though. So let me do my best attempt, and then hopefully you can get something out of this. The first thing you need to do is set the head and the tail equal to each other. So that's what I'm going to do first. So I'm going to say let node equal this.head. This is just a temp variable, by the way, so I have the value of head. So then I'm going to say this.head equals this.tail. And then this.tail equals node. Now why I say that node is a temp variable, because if I set this.head equal to this.tail, and then now I set this.tail equal to this.head, they would be equal to the same thing. So that's why you initially store that temp variable of node. Okay. So now here you can use either a while loop or a for loop. It doesn't matter. What you need to do though is loop over your list the amount of instances there are nodes of your list. So I'm going to use a for loop because it just makes more sense for me this way. But I'm going to say let I equal 0. I is less than this.length. I plus plus. So just a standard for loop. Now I need to come in here and I need to keep track of a previous variable, not a valuable, weird. I'll set it to null initially, and then I need to keep track of a variable called next. I'll set that to null as well. So what I'm going to do is basically, let me just write the code and I'll try to explain it, but I'm keeping track of this next variable. So I'll say next equals node.next. So node, recall, is the head. So I'm going to keep track of the next value after head in this next variable. Then I'm going to come down here and say prev is equal, or sorry, node.next. So this is actually going to change the linked list. Node.next equals prev, which recall at first is set to null. Then I'm going to say prev is equal to node. Node, again, is going to be the previous value of the .next value. This is where it gets kind of confusing for me. And then finally, we're going to reset node. So the list continues to travel. We're going to set it to node, or sorry, we're going to set it to next. So it kind of makes sense. You're keeping track of the next value, which is initially the head, because node is set to this.head, right? So you're keeping track of that next value. Then you're actually physically changing the linked list and then setting node.next to prev, and then you're setting prev equal to node. So basically, this logic right here enables you to traverse the linked list, but then you're setting prev to the previous node of whatever the .next value was. So you're able to like kind of walk it out, but still getting the previous value every time. And then node equals next just resets node. So that's a wordful, and if you can get something out of this, props to you. I still look at it sometimes and I'm kind of confused, but I think I kind of understand it. Okay, let's run this guy and see if it works. So list.reverse. So I should expect to see 14, 294, and 456. And there you have it. That is all the methods you'll probably run across for a linked list. Be sure to like and subscribe this video, and thanks for watching. I will see you guys next time.